This formula is from several of the past IPCC reports. I believe it's originally attributable to a work published by Michael Mann in 1998. Since this is the first time I've mentioned the IPCC, I will give you a quick background on it. The IPCC is a branch of the United Nations. It's a quasi-scientific, quasi-political organization that every 5 years puts out a report on climate change. These reports are monstrous, hundreds and hundreds of pages long, but only the summary for policymakers is really reported on very much. I won't delve too much in this presentation into the shortcomings of the IPCC process, but one interesting thing to remember is in the last IPCC report, number 4, the summary for policymakers was actually written first, mainly by political types rather than scientists, and then it was circulated with a note to scientists telling them to conform their sections to the summary. Anyway, back to the temperature projections. In the last several IPCC assessments, they said that if you look at CO2 without any other effects, without any complex interactions with the rest of the atmosphere, this is the formula that their best estimate of how global temperatures would vary with CO2 concentration. I know it's hard to have any real intuition about a formula this complex, so I've graphed it in blue. The IPCC says that as CO2 concentrations increase, assuming no feedback effects, which we'll come to in a moment, global temperatures should follow this blue line. As CO2 concentrations increase to 650 parts per million or more by the end of the century, from today's 385 parts per million, global temperatures would rise about 1 degree Celsius. Okay, I know what you're thinking. You're saying, Warren, you got to be BSing us now. You're not telling us the truth, because I know I've never seen a forecast as low as 1 degree for global warming. It's always 3 degrees or 5 degrees or 10 degrees. You've got to be missing something. And that's true. There is a second piece to this, and that piece is feedback. This is the one place I'm going to have to teach you a little more science, because feedback is absolutely the heart of where the climate models and catastrophic forecasts go wrong. And so we're going to talk about feedback, and instead of using these charts, I'm going to use props. You can tell from these expensive props that I'm obviously funded by the oil, coal, utility cabal. But anyway, I'm going to put this ball on the bottom of this bowl and start the ball at rest. Now I'm going to give it a good tap. The ball rolls around and around. It's eventually going to come to a stop really close to where it started, because the sides of the bowl and gravity tend to neutralize what input I gave it. Even if I give the ball a good shove this way or that way or that way, everything conspires to bring it back to where it started, to counteract the input I put into the system. That's an analogy for negative feedback. Negative feedback is where a process acts to partially counteract any disturbance to its equilibrium. It's like pushing a car uphill with the brakes on. When I shove a system dominated by negative feedback, the system shoves back. As a result, I might not have as much effect on the process as I thought I would before I started. The opposite of this is positive feedback. Positive feedback is way more dramatic. I'm going to turn the bowl upside down now and balance the ball on its top. In the previous case, even when I gave the ball a very solid tap, it ended up about where it started. Now I'll give this ball the tiniest little nudge. I barely touched it, and the ball is now 15 feet away. This is a good analogy for positive feedback. The system amplified my tiny input and caused that ball to roll a long way away. Small inputs can lead to very large changes in the system, dominated by positive feedback. This is how the feedback multiplier effect works. Let's do an example for positive feedback. Let's presume an initial input or disturbance to the system. This could be some initial CO2-driven warming, or it could be the tap on the golf ball. We're going to assume that the first order feedback from such disturbance is a positive 50% of the initial input. That means the first feedback adds an additional 50% to that initial tap. But there's feedback operating on the first order feedback, so we get a second order feedback equal to the 50% of the first feedback. And then we get a third order feedback equal to 50% of the second feedback, and so on into infinity. Fortunately, we don't have to count into infinity to solve for the final value. This whole infinite series reduces to the equation above, such that our 50% feedback, the final output of the system, is twice the input. In other words, a 50% positive feedback factor doubles the initial input. Any feedback factors of positive 100% or greater actually have even more dramatic effect. Those lead to runaway processes or tipping points. Note that this formula also works for negative feedbacks. For example, a 50% negative feedback will result in a final value of 67% of the initial input. Coming back to our topic of global warming, Warming from greenhouse gases alone, as we saw in the chart above with the blue no feedback line, is really quite small. Even a lot of added CO2 is only able to give a small nudge to the climate system, even by the estimates of alarmists. What really makes for the catastrophe are the assumptions in various climate models of enormous net positive feedbacks. Nearly every climate model you've ever heard of assumes that climate is the ball on top of the bowl, not the ball down inside the bowl. When Al Gore is talking about tipping points, think of the ball running far away from the bowl. He is talking about positive feedback so high that the equations literally go to infinity. A good way to think about it is to picture the Earth climate as your stalled car. Skeptics picture the climate as your car stalled in a parking lot, needing a lot of pushing and shoving to move it just a little ways. Climate modelers, however, assume the Earth is a car pushed precariously on the top of the hill. You give the slightest nudge, and it's going to start running downhill and accelerating just from that small nudge, and it's going to crash into smithereens at the bottom. And note that in this case, the key factor was not the nudge itself. It was the fact that the car was sitting precariously on the top of the hill so that the slightest force would start it running away. And that's positive feedback, and that's the assumption that these climate models are built from. So if you remember the 1 degree blue line above, that's not the climate modeler's final forecast. That's the nudge. That's from greenhouse gas theory alone. Here we see the actual forecast, the final forecast taking feedbacks into effect. Those forecasts vary from 3.5 degrees C by the end of the century, the IPCC base case, to 5.4 C, the IPCC high case, even as high as 10 degrees Celsius by folks such as Joe Romm. And so the answer to our question before about what we were missing with our original forecast of 1 degree Celsius from global warming is that feedback multiplies the forecast by 3 to 8 times in the climate models. So what are these feedbacks? I don't want to talk about all of them, but I'll give you an example. One thing that might surprise you if you only learn about climate from the major media is that CO2 is actually a very weak greenhouse gas. A stronger greenhouse gas is water vapor, and a much stronger greenhouse gas is methane. And so what all these climate models do is they assume that a small nudge of warming from CO2 then puts more water vapor in the air, which is a very big greenhouse gas, and more methane in the air, which is a big greenhouse gas. The extra water vapor results from higher evaporation rates as the world warms, and methane is theoretically released as certain Arctic tundra and frozen peat bogs thaw. The water and the methane in turn cause a lot more warming, and then you get the whole cycle repeated again and again, warming and warming and warming in a recursive manner. And even in this complexity, we're grossly oversimplifying certain assumptions, ignoring time delays, etc. But what you need to know for now is that catastrophic man-made global warming theory is actually a two-part theory. Greenhouse gases provide the nudge, and positive feedback creates most of the warming by multiplying the nudge many-fold. By the way, don't think that this is some weird skeptics version of the theory. I don't believe I've strayed off the orthodoxy in any meaningful way in describing this two-part theory. But it's not well communicated, and there's perhaps a reason for this. Scientists and alarmists love to fixate on greenhouse gas theory, and they love to argue about greenhouse gas theory being settled science. And it's true that many, including a lot of skeptics, will grant that CO2 without feedbacks probably causes about a degree of warming for every doubling in CO2 concentration. This is the best understood part of the science, so it's the place they most want to defend. But recognize that 1 degree is not a catastrophe. We have seen now that the catastrophe results from the multiplier effect of CO2 from feedback. It's this theory of positive feedback, the theory that the climate is a car perched on the top of the mountain, ready to run away, that leads to the catastrophe. The catastrophe does not come from greenhouse gas theory. The catastrophe comes from a second independent theory that the Earth's climate and temperature system is dominated by very large net positive feedbacks. Just to finish off the alarmist case, the rise in temperatures are feared to cause all these different knock-on effects, from changing precipitation to droughts, melting ice, rising sea levels, species extinction, polar bears drown, there's more hurricanes, there's more tornadoes, there's more severe storms, bird migration patterns are disrupted, there's more tropical diseases, there's more acne, there's more suicides, and I kid you not, you can Google it, there's more prostitution, everything. Basically, anybody who writes a PhD thesis nowadays has to include global warming. If you're writing your thesis on ruby-throated hummingbirds, you're going to write about the effects of global warming on ruby-throated hummingbirds, because that's how you're going to get your funding.